So that covers what are probably the most substantial sections, the brief history of the digital twin and what a digital twin is and what it is not. What we're going to look at now is to think about where is the research, where's the current research, and what is the research that we might engage with or pursue. Given the majority of quite mature applications such as Rolls-Royce, I think it is reasonable for us to say, well, where is the research, and start to look in a bit more detail. If any of you have looked at digital twin literature, you'll see there's a lot about what I would call the nuts and bolts, the enablers of the digital twin, but not necessarily about the digital twin as a whole. And we'll come back to that in later sections. Here are two word clouds from different communities. The top is manufacturing, and the lower one is some software. And you'll see terms, we've got terms in there: Industry 4.0, smart robotics, machine learning, artificial intelligence, etc., overall equipment's effectiveness levels. And really the question for us is where do these fit, and are they in the overall system, digital twin, and are they research topics for us that we should be engaging with? So to explore this, let's take a closer look at our digital twin. So I'm going to start calling it as digital twin system. This is based on our definition of a digital twin. We've got the four elements, we've got the four interfaces, and what we can start to do is to unpack that a little more. And each of those interfaces has a functional purpose. And if we go from sort of 12 noon, 12 o'clock, and the interface between digital models and the ability to interact and control, there needs to be some means to generate understanding, to learn, and to make some decisions. Between interact and control and the physical system, there needs to be some level of automation or control, some means to intervene automatically. We then have, between the physical and data, we need to have some metrology and sensing. And between the data and the digital models, there's a need to condition and combine that data so it's tractable or usable within digital models themselves. And we can drill down again and look into those interfaces, and we start to see a number of familiar terms. And if we go from 12 o'clock again, the digital models, if we look at learning and decision-making, things like surrogate models, machine learning, AI, design of experiments, multi-scale modeling, model-based systems engineering, digital thread optimization. We can look at automation and control, actuation, control elements, robotics, self-powered, intelligence, autonomy. In terms of metrology, IoT, sensors, comms, contact, non-contact, some metrology systems. And for data, conditioning and combining, techniques like data fusion, pardon me, filtering, noise, signal processing, pattern extraction, and big data. And if we look at our word clouds again, we can see a lot of those terms appearing. But the question for us is are these distinct areas of DT research, or are they established research areas in their own right? And in fact, many of these are part of or undertaken by computer scientists and colleagues around the world. And that makes it challenging for us, I think, as engineering and engineering design researchers, in terms of what actually is the research, what is the challenge for us in the context of digital twins, and what are the fundamental research activities or areas that we should be pursuing. So is there any research for us to do? Well, if the previous topics identified are not the research challenges, perhaps because they're more about the nuts and bolts, then what are the challenges? I think the key here is to look at the whole, not just the individual parts, and to start to understand its purpose. And actually to do this, we need some design thinking. Ironically, this is another DT, design thinking, digital twin, another DT acronym. But what we want to start to do is to consider the digital twin system and its purpose. What problem is the digital twin trying to solve? So we need to apply some design thinking. And as I said, most reported research is actually about the implementation, the elements or enabling aspects of that implementation. We need to look about the whole, look at the whole and the remainder of that cycle, right from ideation through to implementation. And actually, isn't this what design researchers excel at? Design thinking and applying design thinking to these sorts of problems. So I think this is really important for us to think about, and we're in a great position as a design research community to actually undertake more of a systems perspective, systems thinking, design-led, design thinking research activities.